Hi all. Today's topic is squeeze theorem. Squeeze theorem is also called as sandwich theorem. Statement వచ్చేసి if an, bn, sn are three sequences such that first condition ఏంటంటే an is less than or equals to sn and sn is less than or equals to bn for all n greater than or equals to m, n belongs to m. Next, second condition is limit n tends to infinity, an equals to L, and limit n tends to infinity, bn is also equals to L. Here L belongs to R. Then prove that. మనం ఏం ప్రూవ్ చేయాలంటే ఇక్కడ లిమిట్ n tends to infinity, sn equals to L అని ప్రూవ్ చేయాలి. నా ప్రూఫ్లో మనకేమి ఇచ్చిండు గివెన్ దట్ హియర్ given that an, bn, sn are three sequences and first condition ఏమిచ్చిండు an is less than or equals to sn is less than or equals to bn for all n is greater than or equals to m. Now next condition is limit n tends to infinity, an equals to L, and limit n tends to infinity, bn is also equals to n. For all L belongs to R, we have to prove that limit n tends to infinity, sn equals to L అని మనం we can prove this theorem by using the definition of limit of a sequence definition తోటి మనం ఈ థియరమ్ని ప్రూవ్ చేస్తూ ఉంటాం. లిమిట్ ఆఫ్ ఏ సీక్వెన్స్ డెఫినేషన్ ఏంటంటే ఎప్సిలాన్ గ్రేటర్ దాన్ 0 దర్ ఎగ్జిస్ట్ m belongs to z plus such that n is greater than or equals to m. Then limit n tends to infinity, sn equals to L. Here mod sn minus L is less than epsilon. By using this we can prove this theorem. Here first we have to take this limit n tends to infinity, an equals to L. By the definition of limit of a sequence, an minus L is less than or equals to L. We can here by the removing mod we can get minus epsilon is less than an minus L is less than epsilon. Adding on both equation plus L minus epsilon is less than minus plus L is less than L plus epsilon. Here we get L minus epsilon is less than an is less than L plus epsilon. Then we can write here equation number 2. Here we can write equation number 1. Next, now since by the above same as it is, we can get limit n tends to infinity, bn equals to L. Then also we can get L minus epsilon is less than bn is less than L plus epsilon for all n is less than or equals to m2. We can get here equation number 3. Same by using this, we can use this here. Now m is equals to maximum of m1 comma m2. Then we can get from equation 2 and 1 and 2 and 3, L minus epsilon is less than an is less than L plus epsilon is equation number 2. L minus epsilon is less than Bn is less than L plus epsilon is equation number 3. And from equation number 1, An is less than Sn is less than Bn. If by 3 equations we can get L minus epsilon is less than An is less than or equals to Sn is less than or equals to Bn is less than L plus epsilon for all n is less than greater than m. L minus epsilon is, here we can write total here Sn. L plus epsilon for all n is less than or equals to m. Subtract minus L on by for both, for this. Minus L plus L minus epsilon is less than Sn minus L is less than L plus epsilon minus L for all n greater than or equals to m. Here we can get minus L is less than Sn minus L is less than epsilon. Directly we can write here mod Sn minus L is less than epsilon. Mod Sn minus is less than, by the definition of limit of a sequence we can write here Sn equals to L. Hence proved this theorem.